Hi, I'm Siddhant and I'll be conducting your technical interview today. Let's start. Could you please tell me something about yourself?
Hello, my name is Amitabh Banerjee. I have a special interest in software development, especially in Python programming and object-oriented programming. I attained my degree from Symbiosis University with a BTech specialization, and I completed various projects in the web development, data analysis, and machine learning field. My passion for coding started in high school around other batchmates at the time, and that led me to getting a specialized certification in Python and OOPS as a whole. The reason I did this was because I wanted to understand the impact of OOPS and how it helps us to solve real life problems in the form of code. This specialization helped me better understand OOPS and how to implement it efficiently and effectively, and I'm eager to bring that into a dynamic working environment where I can work as a team in order to solve problems.
Well, I can see in your resume that you've mentioned training in Python and object-oriented programming. So, how was your experience and how did it help you?
During my training, I went deep into the principles of object-oriented programming. We started with classes and objects. However, we quickly moved on to inheritance, polymorphism, and design patterns and other such concepts. For example, I worked on a project where I replicated the banking system. Working on such projects helped me understand how the things we learned in OOPS and Python programming can be applied to solving real-world problems efficiently. Along with that, what it really taught me was how to maintain a clean and organized code base, which is very important when you're working with a team.
What do you mean by object-oriented programming and how is it useful in software development?
OOPS is a programming paradigm that uses classes and objects to structure the code in a way that is modular and reusable. Objects are instances of classes that can both store data and operate on the data as well. OOPS is important because it is able to structure the code in a modular way, which makes it easier to write, understand, and extend. As a result, by using OOPS, developers can create softwares that are more likely to resemble the real-world interactions and are more intuitive to work with. The benefit of writing code this way is that you can reuse parts of the code using inheritance and polymorphism, which makes it more efficient to code when you're part of a team.
What are the four main pillars in object-oriented programming?
Encapsulation essentially involves taking low-level or complex parts of the code and putting it together so as to make sure that the person who's reading the code has an easier time reading the code and understanding the code. Encapsulation essentially involves taking different parts of the code and bundling it together so that the person who's reading or working on the code has an easier time getting through it. It also allows us to hold access to different parts of the code, which prevents misuse of the code. Next, we'll move on to abstraction. Abstraction is a process whereby the coder only sees the relevant parts of the code, so therefore reducing the complexity of the code and making it easier for them to work on it. Next, we'll move on to inheritance. Inheritance allows the coder to utilize a piece of code that has been written before and inherit its properties to be used somewhere else in the code without having to rewrite the entire code again. And lastly, let's take a look at polymorphism. Polymorphism allows objects of different classes to be treated as a part of a superclass. But let's break that down a little bit and understand what it means in layman's terms. Essentially, what we're trying to say is your thumb is a part of your fingers, but all your fingers are not thumbs. So while your thumb is an object in itself, it is also part of the superclass that is called fingers.
Well, you must have heard about classes and objects. What are classes in object-oriented programming and how is a class related to an object?
A class is a set of blueprints for creating objects. It has a set of attributes and functions that are used to create the object. For example, a class named car will have different attributes such as make, model, name, color, start and stop. However, an object goes into these attributes in a more specific format. If we were to take the object of car, we would be taking a look at the name of the car, which would be Camry, the color of the car, which would be red, the make of the car, which would be 2005. Essentially, a class holds the overarching template of what an object should look like, whereas an object goes into specifics and gives what the features are.
Could you differentiate between objects and instance variable in a Pythonic manner?
Object variables, on the other hand, are unique, which means they can have different values for each object. Let's take an example. Here we have a class dog Here we have the class variable species, which will be canine. Over here we'll create an init function to give its properties, name and age, as we have shown over here. Let's move on to creating the two dog objects. Dog1 is equal to dog name and age. Dog2 is equal to dog name and age. Over here we'll print dog1 dot species. This is its class variable, and since we are printing species, we'll get the output will be canine. Over here in printing dog2 species is also a class variable, and we'll get the output as canine. Over here when we print dog1 name, we are calling the object variable, which over here would be buddy. In print dog2 age, we're calling another object variable, which would be 5.
How would you differentiate between abstraction and encapsulation?
Abstraction and encapsulation are both fundamental concepts in OOPS. Let's start with abstraction. Abstraction essentially means when the user is working on the relevant parts of the code and has a more overarching understanding of the code rather going into the complex details. Let's take an example. Let's say you're driving a car. To drive a car, do you need to know the intricacies of the engine? You don't. What you do need to know are the steering wheel, the gas, and the pedal. Next, let's take a look at encapsulation. Encapsulation is about bundling data and methods into a single unit, typically a class, and then restricting certain aspects of that unit. So let's take an example. Let's take into account a door. When you open the door, you can see the handle, you can see the glass on the door, you can see it moving from left to right. However, you can't see the screws on the hinges of the door. That's exactly what encapsulation does.
What do you mean by constructor? And how does a constructor differ from a regular method or a regular function inside a object-oriented programming?
A constructor is a special method that is automatically called when you want to create an object. Whenever we create a class and we add def init, it is a constructor that allows us to create an object. Now this differs from a regular method because there can only be one constructor in a class, and it is responsible for creating an object, whereas there can be multiple regular methods within a class and they do not create objects. Here's an example to illustrate. Let's start a class person. Now over here we have a constructor function def init self name and age. Over here self.name is denoted as Ethan's and self.age is denoted as 27. Now we have another function over here which is def greet self. Over here we'll be printing hello, my name is whatever value we have put in self.name, which over here is Ethan's. This function can be written multiple times within a code. However, this function, which is your constructor function or your init function, can only be written once. Now we are calling an object person. Over here person is equal to person Alice 30. When we call the object over here as person.greet, which is what we had defined up, we will get Ethan's, because in this function we have denoted self.name as Ethan. So despite writing Alice, we will still get Ethan's.
I see you've mentioned about multiple projects in your resume, but I'm wondering whether you've heard about method overloading and method overriding. And if you have, I would like you to differentiate between them as well.
Where method overloading is when you have multiple functions with different parameters. For example, let's say you have 3 functions that define area. In the first function, you are finding area using radius. In the second function, you are finding area using length and width. In the third function, you are finding area using length, width, and height. Now let's say that you type into Python that you want to find the area using radius. It will automatically pick the first function and help you find the area. That's essentially what method overloading is. Method overriding essentially offers information for a class that has already been defined in its superclass. This allows the subclass to modify or extend the behavior of the superclass method. Here's an example to demonstrate method overriding. Over here we have a class called animal. Let's call it a superclass. Over here we have a function def make sound which prints out some generic sound. Now over here we have a more specific class that is inheriting animal called dog. Over here we have added a function as well which which says def make sound self and prints out bark. This function over here overrides the super class when it is specifically called. So over here, when you look at the object animal and you type animal make sound, it will create some generic sound because it belongs to super class. However, when you call the object dog make sound, it comes to the specific class that we have written over here and it will make out a sound of bark. This over here showcases method overriding.
Coming back to classes and object, you must have heard about static methods in object-oriented programming. How does a static method differ from a instance method in an object-oriented programming?
The static method is a function that belongs to the class and not to the object. They are defined using the add static method decorator in Python. They are typically used to perform utility functions that are related to the class but not related to the object in any way. Here's an example to illustrate what a static method is and how it differentiates from an object method. Here we have a class called math operations. Over there we've added a decorator static method and we've defined a function of add a plus b. Right? To call this class, we do not require an object. That is what a static method allows. So we straight away do print math operations dot add 3 and 5. Over here the output will be addition of 3 and 5, which is 8. However, when we want to call this object function, we require an object. Thus over here we have made math ops the object and we have called it over here. Then we did multiply, and over here when we multiply 3 and 5, the output will be 15.
What is a package in Python and object-oriented programming, and why should I as a developer make use of packages?
A package is a way to organize and group related classes, modules, or functions. Essentially, by using packages, coders can break down large codes into smaller pieces, each with a specific responsibility. This helps maintain the structure of the code, and it allows the coders to go back to where they need to when they need to recheck the code. Here's an example of a package structure. Let's say you have a folder in your laptop called Ethan's package, right? You want to convert that into a Python package. First thing we do is we create a Python file called init.py. Now because we have created this Ethan's package becomes a Python package. Now let's say you have two more Python files, one being module1.py and module2.py. Both of them have functions inside them that you want to utilize. So that is why we write this line: from Ethan's package import module1 and module2. Now in order to make use of these functions, we'll write module1.some function, module2.another function. As a result, by writing this, we are able to utilize the functions we have imported from module1 and module2 in Ethan's package.
Well, Amitabh, coming back to your projects, I'm wondering, among all these projects, have you used object-oriented programming in all of them? And I'd like you to describe a particular project in detail.
One of my projects was a library management system using OOPS. I created classes for books, members, and transactions. Each class had its own attributes and methods. For example, the book class had attributes such as title and author, and methods such as check-in and check-out. The member class had attributes such as name and number, and it had methods such as borrow and return. Using OOPS made the system so clear and easy to understand. By using OOPS, I was able to make the system responsible for its own behavior. As a result, it made it easy to understand, and I was able to extend the data and everything when required. For instance, adding new features became much easier with OOPS. And if I wanted to use inheritance, I could create special classes for different members, such as student member and faculty member. 4 main benefits came out in this project as I used OOPS. Number 1, modularity. The code was managed within certain blocks, which made it easy to understand and easy to use. The second benefit was reusability. Because the code was in blocks, I was able to understand what each block did, and I was able to reuse it using inheritance at later instances. The third benefit was maintainability. Because it was so clear and easy to understand, I was able to find bugs easier and I was able to fix them quickly. And lastly, scalability. The design was so straightforward, it allowed me to extend anything I required and bring in new aspects into the code.
How do you handle exceptions in an object-oriented programming environment? And I'm wondering whether you've made use of any custom exception handling mechanisms in object-oriented programming.
In one of my Python projects, I use a try except block. When I put in a certain piece of code to try, and if it didn't work out, it goes to the except block. I did use custom exception classes in my code. It helped me identify the error and make sure the software didn't crash in a much easier manner than it usually would have been. It also made the code much more easier to read, which made it easier to handle. Here's an example of handling exceptions with a custom exception class. You see over here we have written class insufficient funds error. This is our custom exemption class. Here we have made a message as well. Let's keep this aside for now and move on to the first class that we see, which is class bank account. Over here we have defined a self balance, and over here we have defined an amount. Now we have placed a code that says if the amount that is required to be withdrawn is greater than the balance within the account, it will raise insufficient funds error, which is the name of the custom exception class that we have defined over here in this def init, right? If that happens, this message will be shown, which is insufficient funds in the account. More importantly, once this is raised, it will go straight to the except block where we have said insufficient funds as funds error as E, and we are printing out E. It will print out E, which is error. If the amount required to be withdrawn is less than the amount that is in the account, it will execute this block of code where we see that the amount is being withdrawn.
Could you describe the concept of composition? And I would like you to make use of an example to describe this concept.
So composition is essentially inheritance without using inheritance. It basically means when one class has an attribute that connects it to another class. The benefit of this was, in my code, it allowed me to bring together many different data types in an easier manner. And it allowed for a flexible system design. Here's an example to illustrate composition. Composition is essentially inheritance without inheritance. Here we are creating a code and we are using it somewhere else indirectly without using the concept of inheritance. Let's start over here. Here we have written and we have made an object my car where we have said car Toyota Camry. So when we say car over here, it goes to the class car that we have created over here. When we say Toyota over here, it goes to the self make part of the function that we have added in the init function. And when we say Camry, it goes to the model part of the init function Camry. Here you have self make and model as well. However, for the third part of the function, which is self engine, it will go straight up to the class we made in the first place. So this is indirectly, it is not a superclass, but indirectly it is acting as a superclass because engine is bringing it up to this class engine where the object is created.
Well, thank you so much for conducting this interview with me today. And before we wind up, do you have any questions that you would like to ask me?
Thank you so much for the opportunity to interview with you. I really appreciate it. I do have a few questions. Firstly, could you tell me a little more about the team I would be working with if I were to join your company? Also, I would like to know what are some of the key projects your company is currently working on. I would also like to know what opportunities there are for professional growth within the company. And lastly, I'm curious as to what the next step of the interview process is.